See, what do you mean by first hydrolysis of ester? For example, any ester if I am taking CH3, COO, C2H5, okay? Ester hydrolysis using water, H plus as a catalyst, I will break the bond, so I will get CH3, COOH plus C2H5, okay? C2H5OH, an alcohol plus an acid. So I hope you already know what is hydrolysis of ester. Using water, we are breaking the bond of ester into its acid. For example, O, C2H5. We will break the bond and we will get the acid and like the respective alcohol. From the organic part, I hope you already know the reaction. Water will come and attack on the electropositive side. So finally, you will get the resultant acid and acid and alcohol. So this reaction we have to study the kinetics. Kinetic in the sense how speed, what is the rate of this reaction, how speed it is going on, we have to study. For that, what we will do is we will titrate this reaction. We have initially one H plus here, which is like a catalyst, and by the reaction progressing, we will get the acid in the reaction mixture. So we will titrate it to know the reaction, like what is the time of the reaction or how the speed it is going on. Okay, for example, I will take a titration mixture, okay, and a burette with NaOH, okay, NaOH will be there. So this will be having our titrate. So or we can call it like analyte, where the reaction is happening. So while the reaction is happening, we will start the our stopwatch to measure the time. And each time, first initial zero time, when t is equal to 0, we will measure. T is equal to at a time t, we will measure. And finally, when the reaction is completed, that will complete like infinity, we will take the reaction. We will titrate it at this each time, okay? To make the reaction that, for example, the reaction is going on, right? So while we are titrating also, reaction will going on. For make it sure that while we are titrating, we will freeze the reaction. How? We will add either ice or we will make it like very cold condition to make the temperature very low, so that the reaction is like ensured to be freezed. Okay, so first of all, for example, how this titration is working and how we will measure the rate of the reaction, I will say. See, here we know that the reactant is CH3, COO, C2H5 plus H2O. H2O we are already taking in a large excess amount, okay, large excess, okay. Otherwise H2O in the presence of H plus, I am saying, okay, H plus will be there. So H plus will be definitely there, which initiate the reaction, which is acting as a catalyst. So H plus will take H plus as an excess. So we can say that the H plus excess, like the change is not, for example, out of 0.1 or 0.1, suppose 0.01 is reacting from the ester. H2O, suppose I am taking a from the, like it's like from 100, 99.01 is reacting. Okay, so H2O is a very large excess. So the change in the, not H2O, the H plus is in the large excess. So the change in the H plus is almost remaining excess, or H2O. H2O is already, we are taking diluted acid. So whether you are considering H2O, H plus same only, okay. So it is in large excess. So actually this is a pseudo first order reaction. Pseudo first order in the reaction in the sense means So H plus will be in the large excess amount. So almost its amount will be constant. So the rate we know, rate is equal to K into reactant concentration raised to power. So according to this reaction, it should be ester. This is, suppose this is ester and H2O or H plus raised to the power 1. Okay. So in this condition, this is in large excess. So almost it will remain constant. So this is also a constant. This one is also a constant. This one also is constant. So constant multiplied by constant will be another new constant. Okay. So basically this reaction seems to be the first order with respect to ester only. Okay. So we will follow the equation of first order reaction, that is T is equal to, okay, or K is equal to, just a second, K is equal to 2.303 by T log R0 by RT, where R0 is the concentration of ester at time is equal to 0 and this is the concentration of ester at time is equal to T. Okay, so we have to find these two things. We will find using the titration method. How it will work, I will just say now. Just a second. Okay, see, once the titration is started, we know that C2H5 CH3 ester, okay, CH3 COO C2H5 and H plus will be in the reactant ester. So whatever, and it will get converted to CH3 COOH plus C2H5OH. okay. Suppose initially you are taking A amount and this B amount 0 0 at time is equal to 0. okay. At time is equal to T, a particular amount of ester will be reacted, that is X amount of the ester will be reacted, and B almost remain constant, that we know, right? B almost remain constant because we are taking in the excess. Okay, so we are not taking any part of that, and this will be X amount formed. And this also will be X amount formed, but we need this one. Okay, why? Because we are going to titrate a base with an acid. Okay, and at time is equal to infinity, okay, complete, it will be A minus A, complete 0. okay, complete will be reacted, still this will be B because almost remain constant because we are taking it in excess amount. Okay, so now this will be formed A. Okay, this will be formed of A. Now initially we are taking in the conical flask, initial when time is equal to 0, what is there? Ester plus acid. So acid present, okay, acid present. So whatever NaOH, okay, NaOH volume you are using at time is equal to 0 will be V0, and at time is equal to T it will be Vt, and time is equal to infinity it will be V infinity. This is the volume of NaOH used for titration. Okay, so at initially, so what it is going to titrate, if time is equal to 0, it will be V0 will be directly proportional to, you are freezing the reaction initially at the second of initiation of reaction, you freeze the reaction and you did the titration. Okay, so you did the titration, so there which is going to titrate, like H plus present. Okay, so we can say that V0 is directly proportional to B. Okay, and at time is equal to T, Vt is directly proportional to, see what it is there, it's there, like after this X will be there and H plus will be there. Okay, so these two are acid, so in the reaction condition or reaction mixture, B will be there as well as CH3COH will be there, where the NaH is going to react with. Okay, so Vt will be directly proportional to B plus X. Right? Now, at time is equal to infinity, what's that? B, definitely B will be there again, and A is also will be there, which is an acid, completely reactor. Okay, so at V infinity, it will be directly proportional to A or B plus A. B, just a second, B plus A. Okay, so we now know the relation. V0 is directly proportional to VB, Vt is directly proportional to B plus X, and V infinity is directly proportional to B plus A. And what we need, here you can see, we need R0 Cc, we need R0 and RT. Okay, R0 is what? A. RT is what? A minus X. So we need A and A minus X. We need A and A minus X. Okay, correct, right? So if I did take 1, 2, 3. Okay, if I did 3 minus 1, what will I get? V infinity minus V0 will be directly proportional to B plus A minus B, which will be equal to A, right? And if I do to get A minus X, okay, I need A minus X. I got the A. To do A minus X, I am doing 3 minus 2, okay, which will be V infinity minus Vt will be directly proportional to B plus A minus B minus X. Okay, correct, because bracket B plus X will come, when bracket open it will become B minus X, right? Okay, so now what it become? It become directly proportional to B and B cancelled, B and B is cancelled, and you got A minus X. So we got the value of how it is directly proportional. A directly proportional to V0 minus V infinity minus V0, V infinity and A minus X is directly proportional to V infinity minus Vt, correct? So I can say now, what was the equation? K is equal to 2.303 by T log A0 or A, okay, A by A minus X, where A is R0, where the initial concentration of ester, and A minus X is the time at time t. Okay, so which will be equal to 2.303 divided by T log A, what value we got? A is directly proportional to C. Why I am taking directly proportional as the A value? Because I need A by A minus X only, right? A by A minus X only I need, right? Directly proportional to V0 or V infinity minus V0 divided by V infinity minus Vt, right? So A by A minus X is a ratio only, so I can take it here. Even though it is not correctly equal, I can take it here itself. A0 is not equal to V infinity minus V0, it is directly proportional. But since it is a ratio, I can take it directly to here. So which will be equal to V infinity minus V0 divided by V infinity minus Vt, correct? So this is the equation for ester rate constant for an ester hydrolysis. I hope you all understand. Thank you.